Here are the solutions to the review gift 1 for 26 through 40 or 34. So what I have here is just the inequality that you would have come up with for the solution. I graphed it on a number line, and then I also have interval notation. So slowly take a look at these, and I'll talk about each one here in a little bit as far as the fractions. So for 28, you do end up getting x is less than negative 11/19, and I'm still fine if you just want to put that on the number line itself, but I was just showing you just to get some reasoning with it, what two integers it's going to fall between. You don't have to show that though. So looking at 29, here I just also wrote it in set notation in case you still prefer to do that. Make sure it looks exactly like this though for set notation, the set of all y such that y is greater than negative 35. And then this right here was just the solution to the inequality for 30 as well. And 31, we got a fraction, so negative 9/5 is almost negative 2. Technically, it's a little bit closer than that. All right, for 32, this is where the compound inequality started, so we're just left with an in-between statement. 33. Here we had two inequalities joined by the word or, so we solve them separately, graph them still kind of separately, but on the same number line. They're going in opposite directions, and then there's the interval notation that goes along with it. And then for 34 as well, again, we just get a fraction 5/3 or 1 2/3. So again, let me know, either email me or by the next Zoom meeting for my remote students, let me know if you have questions on these. Now, when we look at compound inequalities, typically the ands are going to be in between statements, the ors are going to be disconnected here, but there are some special cases. So I first want to talk about the special words or and how these look on a number line. So in this case, let's say these are our two solutions. My two key numbers are negative 10, and then over here I have a 15. So when we have the two inequalities joined by the word or, all of our solutions, all of our numbers can satisfy one inequality or the other, or perhaps both. So we're going to shade, we're going to do a little test, and we're going to shade where we get at least one yes for an answer. So if I were to, for example, test the number, let's just pick negative 20. Is negative 20 greater than negative 10? No. Is negative 20 less than 15? Yes. So I'm going to shade everything over here below the negative 10. Let's pick a number in the middle of negative 10 and 15. Let's pick a 0. What I'm going to test is 0 greater than negative 10. Yes. Since I get a yes there, I really don't need to test the other one, but I'm going to anyway. 0, is it less than 15? Yes. So all the numbers in between negative 10 and 15 would actually satisfy both inequalities. Let's test a 20 over here. Is 20 greater than negative 10? Yes. Is 20 less than 15? No, but it did satisfy the first one, so I'm going to shade everything over here. Now let's go back and test the numbers themselves. Is negative 10 greater than itself? No. But is negative 10 less than 15? Yes. So in this case, I don't put an endpoint because even though negative 10 isn't included in the first one, it is included in the second. Likewise, for 15, it is greater than negative 10, not less than itself, but because I got a yes for the first one, I'm going to shade over this. So what this means is when I end up shading the entire number line, it's all real numbers, or the interval notation, negative infinity to infinity. So no matter what number you pick, it's either going to be greater than negative 10 or less than 15 or both. So there's a special case. Let's take a look at n is greater than negative 2 and less than 8. We need two yeses in order to shade. So I'm going to put my two special numbers. I'm going to go ahead and pick, let's say, a negative 5 over here. Let's do a 0 in between, and then maybe a 9 over here. So is negative 5 greater than negative 2? No, I really don't need to check the other one. I needed to get two yeses here. I'm only going to get one yes, so I do not shade to the left of the negative 2. Is 0 greater than negative 2? Yes. Is 0 less than 8? Yes. So since I got two yeses, all the numbers in between negative 2 and 8 will work. For the number 9, is 9 greater than negative 2? Yes. Is 9 less than 8? No. So I don't shade over there. So the only area I ended up shading is in between the -2 and 8. Now, because I do need endpoints here, I'm going to put an open endpoint on the -2 and an open endpoint on the 8. And really what we got here was -2 to 8. Now this was separated and we ended up shading in between. So let's see if I could just rewrite this. All my n values here are between, they're greater than -2, which is what this says. N is greater than -2, but I'm going to read it backwards here. And n is less than 8. So here's an example, not to trick you, but just to make you aware that if we see an and, maybe it could be written as an in-between statement, as most will be. So we ended up going through what I call like a yes-no test. With an and, we need 2 yeses for the number to have answered in order to shade. For an or, we just need at least 1 yes. It's okay to have 2, but it's not necessary. Let's go ahead and take a look at this next one. X is greater than 3 and X is greater than 6. So my 2 special numbers are 3 and 6. Let's again just go through the yes-no test. Again, I want to get 2 yes answers. So I'm going to pick a 0, a 4, and a 7. Is 0 greater than 3? No. And as long as I get 1 no, I don't shade. And if I just check the other one, is 0 greater than 6? No. So I don't shade to the left of the 3. Is 4 greater than 3? Yes. Is 4 greater than 6? No. So I don't shade in between the 3 and the 6. But 7 is greater than 3. 7 is greater than 6. So I get 2 yeses over here. So, and see if this makes sense. If I pick a number greater than 6, I'm automatically greater than 3. I have to pick a number greater than 3 and 6 at the same time. So all numbers greater than 6 will be yeses to both. 6 is not included, so I just put an open endpoint here. So this would just be 6 to infinity. All of these numbers in this interval are going to be greater than 3 and 6 at the same time. And then let's try n is greater than 4 and n is less than or equal to -1. Now, even though it's written this way, I have to put the -1 to the left of the 4. That's just how they're ordered. Again, it's an and, so we need 2 yeses. Let's pick a -2. Let's pick a 0 in between. Let's pick a 5 to test. So -2, is that greater than 4? No. Is -2 less than or equal to -1? Yes, but because we get a no for the first one, we don't shade it. For 0, is 0 greater than 4? No. Is 0 less than or equal to -1? No. So that's not going to work. And the 5, is 5 greater than 4? Yes, but is 5 less than -1? No. So we can't shade anywhere. We don't even include the -1 because we need it to satisfy both, and it only satisfies the second one. So in this case, there is no number that is greater than 4, because if we're greater than 4, we're over here to the right of the 4. If we're less than -1, we're over here. We have a gap in the middle. We can't be on 2 sides at the same time. So we get no all the way across, which means we have no solution. So again, these are just special cases. So your assignment today is to go to deltamath.com. I'm calling this Review Gift 1 Additional Exercises. So it consists, again, of 3 sections. You have to get 5 right in a row. You have over the weekend, but I'm giving everyone in class time in class to do this as well. So it's going to focus on interval notation. And what's nice is not only will it give you a graph where you have to write interval notation, it's going to give you interval notation and see if you could graph it. A few more problems with absolute value equations, and then solving some more literal equations. So over the weekend, I will post video solutions to Review Gift 1, 1 through 14, and 5 through 25 for right now. The last part I will post into next week. As always, guys, let me know if you have any questions.